just going to talk about what happens when we change the lift vector. What happens to the airplane's vertical path through the air? So we know that in straight and level flight, our four forces are in equilibrium. So lift equals weight. What happens when we increase lift? So let's, I'll bring the airplane out away from us a bit here so we can see this using the wingtip trails. So reestablish straight and level flight, initiate a climb. We see the curve, initiate a descent, another curve, initiate a climb, another curve, another curve as we initiate another descent. Right, I'm going to reestablish straight and level here at the end, and then we'll bring the airplane back around and basically use it to reposition the camera here. Let's actually fly over here a little bit. I want to get a better picture here of what happens when we initiate the climb. So there we go. Okay. We're just keeping it very, very simple here. We're just talking about the airplane's vertical path through the air and what happens when we change the lift vector. So we see some things right away. We've got a straight line here, a straight line here, and a straight line here. Okay? Now we know, like we said, similar to this flight path here, that anytime we have a straight line, the four forces are in equilibrium. So lift equals weight, and thrust equals drag. Okay, and that's in all these areas where the line is straight, where the airplane's path through the air is straight. That includes a steady state climb, like here, and a steady state descent, like here. Lift equals weight, thrust equals drag. Four forces in equilibrium. Anytime the airplane is moving straight through the air, the four forces are in equilibrium. Okay, so let's talk about what happens on these curved portions. So we have a curve right here, and I'm going to make these different colors here. We have a curve right here, and we have another curve right here. So what's happening on these curved areas? Well, this first one here, the airplane is initiating a climb. Okay, so to initiate a climb, we have to increase lift relative to weight, which means lift is greater than weight in that curved area. All right, let me erase that. And just to help us focus, we're going to go ahead and erase this line since we already talked about it. Let me switch colors here. So what's happening here? Well, we don't have any steady state flight happening between this point and this point. This is a curve. So between this point and this point, lift is less than weight. And we know that because the airplane is curving downwards. So even though it's coming out of a climb here, it's curving toward the earth, and weight is overcoming lift, essentially. But we're manipulating that by decreasing lift. Okay. So that's that curve. I'll go ahead and erase this. All right, we have one more curve here. So what's going on here? This would be the equivalent to a level off out of, even though over here we were reinitiating another climb, this would be equivalent to leveling off out of a descent. And, you know, intuitively speaking, if the airplane is traveling toward the ground, we need to increase lift to bring it back into change its flight path relative to the ground in a positive direction. So in other words, raise its flight path or level it off is the term that we use. I'm trying to be as clear as possible. I'm sorry for tripping over my words a little bit there. So in this area here, from here to here, and even further beyond, because we don't ever level off here, this curve continues, lift is greater than weight.